You ready? Okay. I have a few highlighters ready for this one. I would if I were you. So inscribed. I don't know if that means anything to you right now, but we have polygons with other shapes inside. Okay, that's what we have. So often questions will have polygons with diagonals in them. Make sure you highlight that. I will use the same color for the diagonals in the actual shape, okay? Which create inscribed shapes. And the most common ones are, as you can tell here, do you see the diagonal? It goes from corner to corner. Remember that. It goes from corner to corner. It doesn't go through the center necessarily. Listen carefully. It doesn't go through the center. It just goes from corner to corner. That's a diagonal. So don't be using central angles when you see diagonals, okay? How will you know to use central angle? There'll be a dot in the center and a line will get to it, right? It will actually make contact with the center. This one doesn't. And here you have a diagonal right there. So that is my diagonal. And then you have different polygons that are formed. For example, this one here, what do you see? The bottom here is, it's a quadrilateral, okay? We call it a trapezoid in particular, but it is a quadrilateral, okay? Four-sided. And what do you have on the top? I'm sure you all know that one. It's a triangle. Okay, so there we go. So the diagonal creates two different shapes. And over here, you've got a trapezoid. Trapezoid on top. What do you have in the bottom here? How many sides? 1, 2, 3, 4, 5. It is a pentagon. Is it a regular pentagon? No, but it's still a pentagon. Okay. So there again, I'm going to use the same color for a trapezoid that I used here. Right. So these are the most common. I don't go crazier than this necessarily unless it's a bonus. Okay. So different shapes, just so you see them. Okay. All right. So I want you to follow along very carefully here. If we were to focus on just this triangle over here, this angle up here is what we call the interior angle, correct? Okay, that's an interior angle. So before you start these guys, you're going to start off with finding the interior angle. Okay, so start with interior angle formula. So you're going to go n minus 2 times 180 divided by n. So if you're doing this on your study sheet, a lot of students forget you got to start with that one. And so this one right here, the interior angle, which you've been calculating quite often, you have done it quite a few times. When we cut out these shapes here, okay, there's a bunch of interior angles at these corners, right, that we're going to subtract from the total. So let's go to these shapes. So I've cut them out and I've pasted them here. So you've got, how many interior angles would you have if you cut out the triangle? Just the one. These ones are not the interior angle though. Why not? These ones are, look at this one. This angle and this one, they're not interior angles of this big polygon, correct? You get that part? So there's only one interior angle right here. And we know that this adds up to what? 180. Got it? All right. How many interior angles would there be if I grab that isosceles trapezoid? Is there such a thing as an isosceles trapezoid? Yes. Just like an isosceles triangle, same idea, everything is, the measure is the same. How many interior angles do you have on a trapezoid? If you cut, yeah, you have the 2 up there, right? So you will have to subtract those 2 right there. So I'm highlighting them all the same. What does a 4-sided polygon add up to? The interior angles? 360. Yeah. If you did the table, you remember this. What about the pentagon? If you cut out the pentagon, I know this isn't the prettiest diagram, but I'm just going to go back up to the cutout. Look at this pentagon here. How many interior angles would you have? 3. You got it. I think you're seeing the pattern. Okay, you're seeing the pattern. And so when please be careful on this one, listen carefully. I call this B, correct? This might be a different letter though when I give you questions. Just understand that, okay? I'm going to call it B because I kind of think of the base angles. Okay, that's all I'm asking for. So if you wanted to find B here, what would we use? We would go like this. B is equal to 180 minus I, right? That's I up there, correct? And that answer, make sure you put brackets around it. We would divide it by 2, right? You subtract the interior from 180, and then you split the remainder in half because these are exactly the same. Okay, same idea. What would be the formula for the base angle here? What do we start with if you use this pattern? Instead of 180? All right. Minus 2 interior angles, right? So we're going to go minus 2 i's divided by 2 again. Because if we take 360 and we subtract both of those interior angles, whose interior angles are these? From the original big polygon that you find this one in. Okay, guys? Let's do the last one here. Anybody remember what a pentagon adds up to? We did that today. 540, right? So I'll write that in here. So what pattern are we going to use? We're going to say 540 minus 3 i's. What do you call a fish without an eye? Know that one? Anyways. All right. So this is the last bigger part that we're going to encounter. Okay? These formulas, I would have them on my study sheet along with maybe a diagram. Because just the formula, you're going to, I don't know, I feel like it's not going to work for you. Maybe you even want to have one like this and you show how you cut it to get these. But I think for most of you, let me box this in. Let me be clear. Okay. That is what I would have on my study sheet. And maybe, I'm trying to think the way students think from what I've seen in the past, right? This one is from the big polygon. Okay, that's this is the interior angle of the big polygon that you're first and foremost looking at from the outside. And then you're going to go inside and figure out and do some more work with the inside. Okay, so let's try this. 44. And now I can mix it all up on you. Okay, parallel lines. Right now, don't worry about like parallel lines. That's kind of like the first half of this unit, and this is now we're dealing with polygons, but they will appear at some point. I will make them appear inside the polygon. Okay. Okay. I will do one, and then I'm leaving it in your hands because I know you're capable. Okay. Calculate the values of the indicated angles. So let's do the one we recognize. What's A here? Interior angle, right? This isn't, so I'm asking you for it anyway, so you might as well just do it. So I'm going to go angle A is going to be n minus 2 times 180 over n. Let's count. 1, 2, 3, 4, 5, 6. That's called a hexagon, correct? So angle A is 6 minus 2 times 180 over 6. I think I'm just going to cut to the chase and tell you that it's 120. I think most of you will already remember that at this point. So A is taken care of. Which other one do I start now? C. Okay. First, do you recognize that there's a diagonal in this scenario? No central angle, right? Because we're going from corner to corner. So that's my diagonal. And it cuts it into triangle and 1, 2, 3, 4, 5. Don't forget about the diagonal as a side itself. This is a pentagon. Okay? So this is where it doesn't matter what you want to do. You want to start with a triangle, you want to start with a pentagon. I don't care. I'm going to go the easy route. We all like less work, right? I'm going to figure out what B is. Because if this is B, what's this one? Also B. Thank you. Right? So now, and this up here is an interior angle, correct? Which we already know. We happen to calculate, we've already calculated that. If I didn't ask you for it, guess what? You would have still wanted to do this anyways. Because I always tell you, start with the interior angle. So let's find B. Angle B is going to be 180. You're going to look at your study sheet, and you're going to know that it's this one. Okay? We use this one for inscribed. I will just write that down, inscribed. Angle B is 180 minus 120. Make sure you do the brackets. If you don't do the brackets, you're going to get this wrong. 180 minus 120, we can do some mental math here. So angle B is 30 degrees. Angle C. You can make it very hard on yourselves, or you can make it very easy for angle C. What would be the easiest way to figure out angle C? And I'll show you here something. What's this one here that I'm traveling on the whole time? Interior angle, which we know is? Can't I just subtract this one from 120 to get C? Yeah. Could I have used the pentagon formula, this one here, to figure it out? You see where my finger is right down here? Yes, that's the long way. So you do whatever works for you, as long as you understand what's happening. Okay. Maybe I should do both. Let's go with pentagon. So we have 540 minus 3 i's divided by 2. It's 540 minus 3 times 120, right? Lots of brackets, right? Probably gives you a killer emoji if you type this into your, wherever you're texting, right? Bracket, bracket, bracket. 540 minus 360 divided by 2. 360, 540 minus 360. Am I on the right page here? I think it should be 180 over 2. And so C is equal to 90 degrees. Or the easy way, so I'm going to box all of this. C is going to just be one big box here. Or angle C is going to be 120 minus angle B. Angle B is 30. 120 minus 30? 90, okay? So regardless of how you do it, just be careful, right? See what's happening, but that's how you figure this out. So I'll just make sure you understand that the 90 here is this angle there, and this one here is that one right there. And technically it's this one as well. See if this is 90, what's this one? It's, if you think about it, I don't know if you need to see, right? If this is an isosceles pentagon, if this is 90, this is also 90. Okay? So you repeat what's happening on the other side. This is inscribed polygons for you. Just make sure you don't use central angles, because this is going from corner to corner. It doesn't make any hint that it's going through the center. Is there going to be one with a center? Not in a little while. Not in a little while. I'm going to focus on this right now. Do you see this offshoot here? See that? It's dashed. I make sure it's dashed so you're not mixing things up. But what is this angle here? It's an exterior, which is the same as this one, correct? So I morph this in as well, so you don't forget how to do that, okay? So I want you to try solving. First and foremost, I would solve for these angles inside that polygon. And remember, start with your diagonal. What does it cut it into? What is this shape here? It's a trapezoid, right? And this one, 1, 2, 3, 4, 5. This is a penta, right? So you're gonna have to figure out using the strategies that I've just shown you. Okay, so go to town. You still got close to 20 minutes. I think you can do quite a bit of work here. I'm just gonna tell you which ones I want you to try. 44 to 46. And so this is going to be part of I'm going to have one question on the quiz with this stuff. I'm going to try walking around and helping you, but the key will also be posted shortly, okay? I'm trying to really get you to think here, but how many diagonals you've got? You've got one diagonal there, right? You've got another diagonal here, and you've got another diagonal here, correct? You've got a triangle here. You've got, what shape do you have there? Trapezoid, quadrilateral, yeah. 360. What about here? What would you do with C? Don't use the triangle. It's not a good idea. Can you ignore the green one for a bit? What do you have? What shape is this? Pentagon, you see it? So ignore the trapezoid and just assume that you're dealing with the pentagon, all right, guys? Because is this an isosceles triangle here? No, you can't use it. It's not going to be very helpful, okay? So make sure you do all the way to 46, okay? To be prepared.